Well, thank you for joining me on exercise 2A. We're going to be looking at question 3, which says to use calculus to determine the exact coordinates of the stationary points of our curve, which is y equals 5 plus 8x minus x squared. Because it's a negative x squared, we're going to have a parabola which has a maximum, but never mind, that's not the test we wanted. It says to use the second derivative test to determine if it's a maximum or minimum or horizontal inflection. So let's get the first derivative, which is, and that's, that's 5x to the power of 0, 8x to the power of 1, minus 1x squared. So 5 times 0 is 0. 8 times 1 is 8, and that's x to the power of 0. And 1 times 2 is 2, and we drop the 2 down to 1. So we end up with 8 minus 2x. And therefore the stationary point happens when the derivative is 0. So we let our derivative equal 0 and solve that. So we bring the minus 2x across to be positive 2x. We take that times 2 across to be divide 2, and we get a stationary point at x equals 4. So we substitute x equals 4 into our y. 5 plus 8x, 8 times 4, minus x, which is 4 squared. And we get 5 plus 32 minus 16, and so we've got 21. There is a stat point at 420. Now we check to find out, well, okay, so minus 16, 8, 4 is 32, yeah. We now substitute that into our second derivative. We substitute x into the second derivative to test. So text x equals 4 in d2y dx squared, and d2y dx squared is, now there's the derivative, that's the first derivative, so it's 8x power of 0 minus 2x power of 1. So the second derivative is 8 times 0 is 0, and minus 2 times 1 is 2, x to the power of 0. So we've simply got 0 take 2 times 1, negative 2. Now since the derivative is always negative, so therefore negative second derivative is negative, therefore it's concave down. And concave down stationary point is a maximum stationary point. Maximum stationary point. I hope this has helped. So we've got a maximum stationary point at x equals 421. I hope this has helped. Until next time, stay happy.